So we'll start in. Thanks. So with me, I have my colleagues Mabel and Dr. Chu. Dr. Chu gave the talk just now on the stats program. So I will try to continue and talk about the DSA program. So let's give a couple more minutes for people to join, and then we'll start at 2:03. All right. Okay. Good afternoon, everyone. So my name is Vic. I'm the assistant head for the undergraduate program. Just now, Dr. Chu is the deputy head for the undergraduate program. So together, we help to manage the two undergraduate programs, or rather, the undergraduate programs in the College of Humanities and Sciences. Okay. So earlier, we heard about the ST majors. So in the next 50 to 55 minutes, I'll try to tell you more about the data science major that we have running in the program. So I know there are a lot of questions. My intention here is to try to lay out, when you come to the program, what you will learn and some justification or some background about why this is necessary. If you ask me, data science is still quite a new discipline. It's only been around maybe 15, 20 years, but it has exponentially grown in terms of the number of people practicing it and the number of techniques you need to know in order to become an expert. And then the complications about this discipline have been compounded by the introduction and the incorporation of AI into the workflow. Okay, so we'll try to talk a little bit about that at the end. If you have questions towards the end, you can put them in the chat window and I'll try to talk about them. All right. Okay, so let's go. All right. The first part of my talk is all about some of the greatest hits of the DSA major. So what I would say is I'll try to outline some of the domains and some of the disciplines in which data science has been applied and come to bear a lot of fruit. Right? So one of them is in healthcare analytics. This is a very promising area that data science has been applied to, simply because it's near and dear to everyone's heart, right? Here are some of the ways in which predictive data analytics has been used and has been shown to bear fruit. Okay, number one, the first bullet point I have here is on clinical predictions. So what do we mean by clinical predictions? This is where a doctor has some information about the patient. Maybe you go for some diagnostic test, and along with the results nowadays, or you go for an imaging scan. Along with the results, there will be some kind of prediction that tells the doctor or recommends to the doctor this person is at risk of this disease. It is highly likely that this person has torn this particular ligament or this muscle, or their cholesterol level is at high, they're at risk for this particular diseases. So those kinds of predictions are one way in which data analytics has been used in healthcare. The examples that I just gave you are very basic. It goes beyond that. It takes into account the individual patient's age, gender, ethnicity, and so on, to try to make a more personalized prediction for the patient nowadays. Disease progression and comorbidities. Okay, so once a patient falls ill and comes and is hospitalized, right, then analytics is used to try to make some prediction about what complications the person will have, how long the person still has to live if, God forbid, it's a terminal illness, right? So some prediction about how fast the disease will progress, to what stage it will progress, and so on. This is another way in which data is being used to assist in healthcare analytics. The next few, right, are not really related to patient care in terms of prognosis and diagnosis and treatment, but it is more about the logistics. This is a big industry as well. It's sometimes we miss it, right? We don't talk about it. We talk more about the patient-facing side. But hospitals, they need bed space. They need doctors. They need staff. They need nurses. So if people are staying longer, the hospital beds are used up, then new patients cannot get admitted. So analytics is used in a lot of our big hospitals to try to predict how long a patient may overstay. What is the likelihood that if we discharge this person, they will get readmitted? What's the likelihood that there will be this particular complication that they will need to be readmitted? So if a team is able to have this information, what they can do is, it's a bit like what we do with cars, right? We do predictive maintenance or maintaining buildings, air cons. We try to predict when something will fail. We know its mean time before failure, so we try to take some action. If we know that this person has a high chance of being readmitted, sometimes the hospital can send a person out to the home and check on them to see if they are there, to see if they are doing okay, and if we can prevent them from needing to be readmitted, then the hospital has more space. Resource allocation, how much money to spend for different departments in the hospital, which one is getting more patients, which one is requiring more patients that require more expensive treatment, right? So resource allocation. Supply chain management, this was a big thing during COVID, right? We needed masks, we needed vaccines, and it was cowboy country out there as far as what I've heard, right? Trying to secure the right amount of supplies for each country that was dependent on who you knew and so on, and whether you could get the bulk actually delivered to your country. Right? So this is a big area, personalized healthcare analytics. And it's only going to get bigger because of a lot of personal data that we are amassing. Almost all of us use like a Fitbit or a health tracker, and all this goes into Google. So all that can be used to track our own healthcare, to try to predict if we're overtraining, if we're undertraining, and so on. So all this is a huge market. So this chart that I'm showing is from Fortune magazine. They predicted that the value of the healthcare analytics market by 2032 would be $180 billion. That's huge. Right, it's 9 times what it is in the last year, 2024. So this is one domain where there's been very big success. Second domain is in finance. Now, machine learning models aim to prevent fraud. So one of the areas in finance that machine learning is used a lot, and data science, is in fraud detection. So this chart comes from Forbes as well, and it shows the major kinds of fraud that have been carried out in the insurance industry. So most of it, ironically, because what we were talking about in the previous slide was healthcare, the largest section of fraud comes from healthcare, right? 105 billion amount. So how is machine learning applied here? Now, this is not AI, okay? When it comes to AI, I tend to refer to that under the category of generative AI. So this is a little bit more classical machine learning, where we train a model to do a particular thing. You can incorporate AI models to do machine learning predictions, but until now, even without the AI component, the machine learning models have been able to achieve quite a bit of success in handling insurance fraud. Okay, so what kinds of models do we have in insurance fraud? Right, we need to have, if a person is making, let's say in a company, they are allowed to make claims without approval up to $1,000. So if there's a pattern of behavior from a particular employee where they keep making claims of $999, 999 a few times, so they don't have to get approval, but they keep making the claim, that is something suspicious. It's an anomaly. People are not supposed to do this. So that kind of anomaly detection automatically happening, right, is one of the ways in which machine learning models can help. This is not easy because by definition of the word anomaly, it doesn't have a pattern. So to be able to pick something out that is standing out from the rest without knowing in what way it's going to stand out is the challenge of anomaly detection. And machine learning models, there are various ones that can do that, outlier detection. Identity verification, this is another area in which machine learning models are used. So if you've used SingPass, if you used GetGo, or a lot of other apps nowadays, they require you to take a video of yourself turning right, turning left to identify or verify whether you are the person you say you are. Let's put AI aside. Whether these models can detect if this was an AI-generated image of a person, a video of a person, or whether it's the actual person, that's a different problem. But actually matching the video to the person who signed up for the account, that's what we mean by identity verification. Okay. Phishing scam detection, again, there are various features that people engineer put into the model so that they can help to detect things like, has this email address been used to send spam email before? Is the content of the email something to do with money or asking for donation or from certain parts of the world and so on? Okay, so machine learning models traditionally have had good success in things like this. In finance, continuing with finance, right? So scams are a very big problem for all of us around the world. In Singapore, we have GovTech. They've actually developed their own model called SATIS. It's an in-house detection model to help with scam detection at scale. So the numbers on the right in the chart show you how the number of scam cases have increased over the past years. They show no signs of going down. But I think I'd like to show a bit about this website. If you click on one of the links, it'll take you to GovTech's website on SATIS. Okay? So the model that they have come up with is called SATIS. And I just want to highlight a few things. Okay, so I hope you can see this. So it says it's an AI-powered platform aiding the Singapore Police Force in combating scam websites. Okay, it uses an in-house AI classifier to evaluate 400,000 websites daily for potential scam. This is impressive, right? No human can do this. And this is the value that data science can bring to a problem. It can automate things at scale and get things right most of the time. 100% accuracy is not likely. And I'd like to ask you, do you think this is a reasonable expectation? Even for humans, we cannot hit 100% accuracy. We try to get our machines to get close to that. And if they're good enough, we accept them for operational use, right? So another thing about data science is we always focus a lot on the metrics. So we try to come up with different metrics for different problems that are appropriate, and we try to see whether our models can achieve those targets. But the main thing I want to highlight here is this. Okay, so there is still human verification. It benefits from citizen reporting of suspicious sites via Scam Shield. So Scam Shield is an app that we all have that can help to alert you if a particular phone call or a message is coming from a known scam number. Why I'm highlighting this is because data science solutions are not silos. Data science, and we'll see more of this as the talk goes on, data science problems are one cog in an entire machine. There are humans involved, there are users involved, there are data from different sources involved. A good data science solution has to be able to coordinate these inputs, incorporate all of them, ingest all of them, and come up with a good prediction, a reliable prediction, an explainable prediction. So data science solutions are not just you take a model, you put in one data set, you come out with a model, and you throw it to the client. It doesn't work like that. This is one of the things that I'd like to stress. It differentiates data science from other disciplines that also use the similar tools. Okay. All right. So back to the slides. Okay, this one is a bit lighthearted in terms of what it's showing. It's showing this is a chart from Grab. Grab has a lot of data on us as well, and they tend to release some of these newsletters that say these are the most frequently ordered bubble tea flavors, most frequently ordered things on their food delivery, and this is the most popular destinations for Grab users in 2024. 52% want to go to Southeast Asia, East Asia, and then Europe, Oceania, and others. Okay, so how does Grab use this? The things they show us are a bit lighthearted and for fun, but how does Grab use it? They use it to decide what kind of promotions to give us, who to send the promotions to, if they know what particular food a person likes, they will send them promotions and so on. And they will start to contact the sellers. Are you able to give certain discounts to the people? It looks like many people want to travel to your part of the world. How can you help? How can we boost your profile on Grab? Okay, so this is how Grab uses the data. E-commerce is a huge area of success for data science. All right, but data science is not all perfect. So the next couple of slides, I want to show you that we have to be very careful when we use data science. And this is one of the reasons why we cannot surrender data science solutions development and deployment completely to AI tools. We cannot rely completely on vibe coding for data science solutions or any solution, actually. Okay, so here's the background. In 2018, it was reported that Amazon had been working on an AI-powered tool to review resumes. There are a lot of resumes that come into the HR department, and it's hard for them to screen all of them accurately and quickly and without missing any good candidates. So they worked on an AI-powered tool. AI-powered tool means that it has to screen the text of the document, pick up their experience, identify whether it's relevant to the job they're applying for, and then put them up as candidates for second round, maybe, right? But it didn't get deployed because in testing, it turned out to be heavily biased against women. So Amazon is a tech company, one of the big tech companies, and a lot of tech companies, they have a high percentage of males working in the environment, in the companies, traditionally, right? But we're trying to change that. Everyone's trying to change that. But if we continued with this AI-powered model, it would just have perpetuated the bias. This is just a manifestation of the model's behavior in that particular instance. So the underlying cause was probably how the models were trained. Now, how the models are trained depends and affects greatly how the model can be used in deployment. So in particular, right, some of the models, when they are trained, they are just thrown huge amounts of data. The internet has become a huge resource for natural language data. Even though there's copyright on the internet, you're not supposed to be scraping websites willy-nilly and without any without regard. People do it, especially those who train the models. And when they train the model, they point their crawlers or their scrapers to those where there's a large amount of data, a lot of conversation, a lot of different voices, which is websites like Wikipedia, Reddit, social media websites. Because a lot of people are there, there's a lot of information, a lot of topics being discussed. Now, Wikipedia is okay. Wikipedia is one of the most reliable sources. It is self-correcting, I mean, in the sense that there are other users that will correct things and so on. So Wikipedia becomes a very good source of a lot of the search engine's data. But things like Reddit, they're very opinion-based. If you looked in today's papers, there's a huge article about how the Singapore forums in Reddit, they're very biased. There are certain moderators in some of those groups who kind of put people into echo chambers. Actually, if you come next week for our physical open house, we will demonstrate a product. During one of our in-practice courses, a few of our project groups, they worked on a data science solution to try to help people get out of their echo chambers. When they surf the net, maybe they get stuck in a particular point of view. They don't even realize it. They go deeper and deeper. But we need some data science solution that can detect them and snap them out of it. So next week, if you come to our booth, we can show you one of these solutions. It's not a perfect solution, but through that solution, we'll try to show to you what students in the program learn, what we try to emphasize, and the promise of the output that they can create. Okay, so back to this example. Let me demonstrate to you how some of these models have a particular bias. So word2vec is a particular model. It's a model that converts words into numeric vectors. So a vector is just a sequence of numbers that can represent something. Typically, we can use vectors to represent coordinates in X and Y plane. But it doesn't have to be just two coordinates. It doesn't have to be X and Y. It can be X, Y, Z, A, B, C. It can be a really long vector. So word2vec, the job is to convert any given word into a numeric vector. Okay, so if I give it the word review, it should convert that into a particular vector. If I give it a different word, deploy, it should convert to a different vector. All right? Okay, so then to test the model's performance, we apply what's known as an analogy test. We will ask the model, I give you these two words. If you've taken a GRE or if you've taken a verbal written exam like the SAT, some of them ask you for analogy, some of them ask you to perform the analogy task. So they will give you man is to doctor as woman is to what? Okay, so we ask the model the same question. So man is to doctor as woman is to. It turns out that Word2Vec will return gynecologist. So the point is that Word2Vec is a little bit biased against the female gender. So for a man, he can be any doctor. But for a woman, she has to become a gynecologist in Word2Vec's mind. So this kind of underlying bias, if we continue to use the model, will be perpetuated. And it's no fault of the. Actually, this is another scenario. If someone were to use this model and it turns out to exhibit this bias and someone is offended or some huge liability results from it, who is to blame? Was it the model developer? Because the models are developed usually under very loose licenses like GPL, which means that if you use the model, the liability is yours. The person who developed it takes no responsibility. So should it be the person who uses the model, but they may not understand what went into the model or what the biases are? Right, so this is again a very quicksand kind of ground to stand on, but the bias exists in the model. I'll give you another example. So instead of man, we put father. So father is to doctor as woman is to. Any ideas? So the model will return nurse. So the woman will be will not be put on an equal footing. She may be so it exhibits a bias against the nurse, right? So yeah. So this is a problem with Word2Vec. Okay, so these models, if they are trained, they have to be checked for the kind of bias that they exhibit or they have kind of been trained with. It's usually a result of the data that they're trained on. Okay, so starting from the excellent performance that data science models have, I'm trying to get you to highlight that it's not easy to get models to do good things. We see a lot of the success stories, but a lot of the failures we don't hear enough about. Okay, and if we do, it's helpful because we can learn about them. We can try to avoid the mistakes again. Okay, so now let's segue into what a data scientist does day to day, the job of a data scientist. Okay, so here are some cartoon skits that a colleague of mine made. They're AI generated. So she and I, we came up with a script and they asked one of the AI tools to generate the images. Okay, so let me read it to you. So in the morning, the individual on the right, the guy with the glasses, he's the data scientist. So in the morning, he has a Zoom call. This is what data scientists do like daily. Usually they will have a stand-up call. A lot of times they work on the agile methodology, which means that they meet very frequently. They set themselves a 10-day window to achieve a certain target. Then they work intensely for those 10 days. And if they cannot, at the 10 days, they take stock and they reevaluate their targets. Okay. So every day they'll have what they call a stand-up meeting. Stand up because everybody stands up, nobody sits down, so that the meeting is short and efficient. Okay. So at the meeting, the boss asks the data scientist, what did you accomplish yesterday? And he starts to wonder, oh, should I tell the truth? And in his mind, he's running through everything that happened yesterday. He was trying to write some code, and he spent 6 hours debugging a pipeline or a piece of code only to realize it was not working because of a missing semicolon. This is more common than you would believe. It's happened to me a lot of times. And a small bug can lead to a big problem. To trace it down takes time. It's inevitable that you have to do it. But sometimes it's unappreciated, the amount of time that's needed. So instead of telling the entire truth, he kind of gives a more decorated answer. Let's call it a decorated answer. He says he was optimizing his code yesterday. Okay. All right. Second scenario, he starts running a program. So when we run data science solutions, there's a lot of training of models involved, especially when it's a deep learning solution. Training can take a lot of time. We don't always run it on our laptops. Our laptops don't have the kind of horsepower, computing power to do the training. So we usually run them on servers, cloud computing servers like AWS and so on. Okay, so he sends it to run. And the most frustrating thing about these long-running pieces of code is that sometimes they crash halfway and you've lost everything in between. Okay, so when he comes back, he's actually very surprised and pleasantly surprised that it worked. And he celebrates the victory, right? Today is a good day, right? Yes, we do drink a lot. Okay, I do drink a lot of coffee. Okay, so this is another angle that I want to highlight about what a data scientist does that I feel is quite specific to the job of a data scientist. If you ask me what is the definition of a data scientist, I don't have a specific one, but a data scientist has to work with a lot of data, has to know a lot of coding, has to have a good foundation of statistics and mathematics, and has to be able to communicate. This is quite often overlooked, the ability to communicate what you have done, how good it is for the client. Previously, we would, before this era of data scientists came about, where it was so widespread use, we would run the models and then we would step back. Then it's up to the client. What they do with it is up to them. Whether it works out after that, we would step back. But now, no. We have to convince the client that it is useful. We have to come up with creative ways for them to use it as well. Okay, so the client asks the data scientist, can't the model just predict everything with 100% accuracy? Okay, so he starts to roll his eyes and then he looks in his crystal ball and he says, yes, let me consult it. But then he comes up with an epiphany. He says, let me give the client an analogy. Look, you use Netflix, right? And when you watch Netflix, even though it recommends movies to you, it's not always a hit. Sometimes something that's highly recommended to you turns out to be something you would never have watched, right? And the client gets it. So the ability to talk in the client's way of thinking, the client's way of communicating is very important for a data scientist. And every client is different. Every domain is different. So the data scientist has to be a bit of a chameleon. He has to be able to understand what the client needs and communicate that properly. Okay, so this is just a summary of what I was talking about. Maybe I can go into, because the data scientist role, when you have looked, if you have looked online for, let's say, data scientist jobs, there are different kinds of roles that data scientists can go into. A broad idea is they are trained in data science, but not all of them do the same thing. If you look on the right, there are 9 boxes where there could be different roles that our students will go and fulfill. Some of our students end up working as an actual data scientist. Some of them work as data analysts, some of them work as data engineers, statisticians, NLP engineers, and so on. So there are many different roles. They are basically, with the same training, you can kind of branch out into different aspects of the pipeline. And they're all working on data science solutions, but they may be working on different time points of the solution, right? So for instance, a data engineer, his job is to have an effective and streamlined pipeline for gathering data, cleaning the data, ensuring the data is valid, indexing the data so that it can be retrieved very quickly and very efficiently by the data scientist later on. Then if a new model comes, he has to have efficient ways that it gets trained. The model gets updated to a more accurate one, to the new version. And that's not enough. If you have a new version for a model, you can't just throw it out there immediately. You have to try it out. You try it out, maybe you do some A/B testing to see whether the new model really has an improvement over the old one. If there isn't, you got to roll back to the old model, which means you cannot throw away the old model, which means all previous models have to be indexed, checkpointed, and ready to retrieve and use again. So that's the data engineer's job. Okay, so the role of a data scientist in practice, right, is very varied. The training that we try to provide in the industry, in the program, gives you a foundation, but there are a lot of nuances that are dependent on your role in the company, the domain that the company is working on, and so on. Okay. Okay, so on the left, we have a few kind of stages that the data science team or the data scientists will go through in a data science project. So usually they start with coming up with a project. Then once you've identified the data that you're going to use, there's data wrangling. You've got to get efficient pipeline to get the data into your models, and then analysis. And some of these are not linear steps. For instance, at this point, you're supposed to get the subject expertise. So this is what I was trying to allude to in the previous comics, right? the data science solution cannot happen on its own. You always have to communicate with the person who is the expert in the domain. Like in e-commerce, if the marketing team comes to the data science team and says, hey, we need to run a promotion for 99 sales. So then the data science team will ask, okay, have you identified which particular country you want to run it in, which particular industry? Is it F&B or is it sports equipment or something like that? And then the subject experts will say, okay, we've noticed that around this time, a lot of people start playing pickleball. Then they will try to highlight and target pickleball players. So they look for consumers of a particular age group, living in particular areas where there are pickleball courts, and then they try to send them promotions and so on. So there will be a lot of back and forth and communication with the subject expert. The data scientist shouldn't have the impression that what they're doing is just run a model, give it to the client, and that's it. Okay, so there will always be back and forth. There will always be a need to learn the domain, learn the specific problem setup before a solution can be provided. Okay, and then the last few is designing the product and then communicating the results. Okay, so these are the things that data science roles, these are the types of data science roles there are in companies that our students go into, and the kind of day-to-day tasks that they do. Okay, so in our program, if we can give like a broad level description, right? Data science has hard skills and soft skills that you need in order to be a good data scientist. So like I was telling you, you need to be able to be creative in problem solving in terms of what data to get, what techniques to apply. You need to be able to communicate well, which is what we mean by storytelling. You need to be able to collaborate with the client, with other data scientists, with the people giving you the data, and with the people finally using the model. Okay. You need to be curious to try to find out about what other techniques people use, what other solutions people have used in the same domain, and so on. Okay. Communication and creativity touches slightly on storytelling as well. Okay, so let's go to the hard skill. So you need subject matter expertise, and this one I'm referring to the particular techniques that are used in this domain. Whatever domain you're in, they will have their own specific set of techniques that they favor. So you need to find out what those are and become a bit more of an expert on those. Math, stats, and data technical skills, these are fundamental. These are things that we try to build up in the program. So you need to have ideas, knowledge about calculus, probability. In terms of statistics, you need to know how to derive certain estimators, how to judge whether certain estimators are good. What do I mean by that? So if you have a set of numbers and you're trying to predict a new observation that's going to come in, you just have one set of numbers. Some people will tell you, use the mean, always use the mean, but it may not be appropriate. You may want to, if you notice that your data has a lot of outliers, you may want to use the median because it's more resistant to outliers. It won't get so affected by outliers. So when do you use the median? When do you use the mean? What are the properties of the median? What are the properties of the mean? Those are the kinds of things that we try to teach in our courses, like statistical inference, ST2132. Mathematical statistics, okay? So those are the kinds of knowledge that we're trying to get across, okay? So you need this. This is one of the things that's very unique to data science. You have the soft skills cannot be overlooked. You have to have both in order to be a good data scientist. And this will be reflected in our program. A lot of the questions we get are, what's the difference between stats and data science? What's the difference between School of Computing and data science, business analytics and data science? This is a key difference. Okay, so not everyone can be a data scientist. This is something that I try to get across, and it's not to put people down. Since we were young, sometimes we've been told you can be anything you want to be when you grow up. That's not true, in my opinion. It's not a realistic point of view. We can try our best. That's not a reason to not pursue our interest or our passion. But there are certain things that we are better at. There are so many things that other people are better than me at. I cannot just say I'm going to be the best in every single thing that I try. When I was a kid, I wanted to be a professional footballer. There's no way I can be one now, right? It's clear to me that I don't have that genetic skill. I don't have that athletic ability, right? So being a data scientist requires a certain way of thinking. Like we tried to highlight in the previous slide, you have to be able to formulate the problem in a certain way. Okay, so let's go to some of these. The links below show you certain aptitude tests that people give. I don't believe them, but it just goes towards the idea that to be a data scientist, you should have a certain skills in thinking certain ways. Okay, so some of these examples are, so if you click on that link or you go to polev.com/Vic Gopal, let's take a look at this. Okay, so which word does not belong with the others? Okay, so I'll wait until maybe one or two people. All right, so the idea behind some of these questions is that you should be able to identify kind of like patterns within words or within, it doesn't have to be words. In this case, it is words. It requires you to have a bit of background knowledge about things to do with the eye. But as a data scientist, you will do this. You'll be looking at data sets, you'll be looking at visualizations of the data sets in different ways. If your data has 10 columns, you take 3 of them at a time, 4 of them at a time, and you try to look for patterns. Hey, this group of things look similar. This group of things are similar because of these particular characteristics. So as a data scientist, you have to do this all the time. And that's the kind of skill that they're talking about, even though this looks a bit more like an English question. And if you ask me, I think the answer to this is vision, because the other 3 are actual parts of the eye, whereas vision is something that the eye helps you with, right? So, but the other 3 are physical parts of the eye. So being able to identify that this group of things are slightly different from the others because of this, that's a skill that a data scientist has to have. Okay, let's try another one. So I think I should clear the responses. Okay, again, this is about trying to look for patterns. Sometimes this goes to the extreme. Okay, so here are some words translated from an artificial language. Koda bim means kidney stones. Roms bim means kidney beans. So perhaps from those two, I conclude that bim refers to kidney. Roms bako means wax beans. So ROMs perhaps means beans. So what word could mean wax statue? So wax probably means ROMs, right? So probably I'll use ROMs peel, right? BIM means kidney, ROMs. Yeah, but you see ROMs here as well. So ROMs maybe, so Bako means wax, right? So probably it's Bako. Yeah. Okay, so these are the kinds of patterns, and you've got to have a bit of logic thinking along with it as you do it, right? To try to figure out what is the right logical conclusion. Okay. So these are the kinds of questions that they have on these aptitude tests. It doesn't mean that if you get all of them correct, you can follow those links and try some of them. It doesn't mean that if you get all of them correct, you automatically become a data scientist. And it doesn't mean if you don't get any correct, you cannot be a data scientist. But my point was just to get across that there are certain ways of thinking that a data scientist has to have, forming patterns, making hypotheses and testing them, retesting them. And if those fail, you go back to make a second hypothesis and you test again. It's in line with the scientific way of thinking, but you have to be very kind of rational when you do a data science project. Okay, so let's go on to our actual program. So a little bit more details about the program. There are certain CHS common things that there are certain CHS things common that I won't go into, but I'll try to highlight specific to our data science program. So it's an honors degree with primary focus on data science and analytics. To get into the program, just like Dr. Chu was saying just now, you come into the College of Humanities and Sciences, and then you choose data science as your major. You will, as long as you get into the CHS, no one will stop you from taking data science. It is your choice, it is your prerogative. Once you're in NUS, in the College of Humanities and Sciences, there's no quota. You will be, as long as you declare it in your semesters, you will be put into the program. Okay, and it's up to you to fulfill the requirements and then graduate the DSA major. Okay, so it's offered jointly with by our department, the Stats and Data Science department, along with mathematics and with the School of Computing. So mathematics provides some courses. They help to mentor our students as well. And School of Computing helps us with some of the machine learning courses as well, and the programming fundamentals courses. Okay. If you want to remember at CHS, you have common curriculum of 13 courses. 15 courses become your major, and then you have 12 units, that's your undergraduate elective, right? So you can use those UE space to become more of an expert in data science. And the two specializations you can focus on are operations research or statistical methodology. Okay, so the curriculum, the program is designed with sufficient technical depth because, like Dr. Chu was saying also just now, right? The field is changing very quickly. So what we teach 1 year in a few years may become more of like a basic model. And then you need to know more about the advanced models. So when you go out, you have to have that ability to teach yourself. In order to have that ability to teach yourself, you have to have a good, strong, deep foundation. So we try to be as technical as we need to in at least the first 2 years of our courses, learning the calculus, the probability, the linear algebra, statistical inference, and so on. And then after that, it's a lot of application. Okay, so we have a breadth of application modules, which I'll come to in the next couple of slides. Okay. Okay, so we see this as the foundation of the program, computer science part, the mathematics part, the statistics part. So these are exactly the courses I was referring to just now. In computer science, in your first year, you will learn the Python courses. As you progress, you will learn about machine learning algorithms, about data structures. In mathematics, the key topics that you need are linear algebra and calculus. And both of those will feed into the statistics side. The calculus is very important for probability. The probability you see at university is very different from what you've seen at A-level. There, a lot of focus is on testing and on combinatorics, but probability is a lot more than that. And calculus is the most important topic that you need for probability, okay? Inferential statistics is what I was talking to you about, like which estimator is better in which case, how can I come up with a new estimator and assess its qualities and so on. That's the inferential statistics I was talking about. Michael Choi, the video that Dr. Chu showed just now, he's the one who teaches the inferential statistics course. He's one of the professors. In terms of then the practical tools, we also try to cover. Visualization is a very key class that we cover. This is DSA 2101. It used to be taught in a language called R, but recently we've switched to Python. And actually soon in our entire program, we'll use only Python, okay? Regression analysis and machine learning, these are fundamental modeling techniques that all data scientists need to know. So those are courses that are covered. And the in-practice courses and sense-making courses, these are where the skills that I was talking to you about, like the cartoons, right? Where the person has to communicate, where he has to formulate the problem, where he has to explain what he's doing to justify and explain his models. This is where you get explicit practice on these. Some of you will argue that maybe this one can be done, can be picked up on your own and so on. But we realize it's better if we have explicit instruction and explicit opportunity for students to practice this. So our in-practice courses, we have one, it's called DSA 301, but the people who teach them, we have two practice track professors who used to run their own startups. One of them used to work for Visa. Another one has huge breadth of industry connections. So they know exactly what's going on in the industry, how data science solutions are done, what kinds of problem people work on, what's the workflow that people have in the companies and so on. So they are the ones who run our in-practice course. So one of them right now, he's teaching the in-practice course, and in the course, he has gone to look for about 20 plus projects, live projects, just for students to work on. He has negotiated with the companies to say, okay, we have students who work on this. They will go a long way, but they are still learning, but can you sponsor some projects? So he went out to look for them. So even without having to go for internships, students are having the chance to work on live projects. Okay. So this is the in-practice that we talk about. The students get a chance to talk to a client, to try to defend their solution and their workflow and their thinking process to the client, and they deploy the solution. So these are things that make our program stand out from other programs. And I believe this is what will be the difference, if you ask me, between like the School of Computing, business analytics, and with the stats majors. Because the stats majors, they also don't take, they have, the data science program has a lot more coding, and these in-practice courses, they're an integral part of the data science program, but the ST major replaces those with stronger statistical methodology courses. And on top of the in-practice course, which is a core compulsory course, are the sense-making courses, where we get adjuncts who are currently high-level data scientists in their companies. They handle the whole course from start to finish. So they teach the students about their domain, about the problems in their company. They provide data sets. Then they guide the students in project teams to try to solve the problems. So these are very popular. We try to control the numbers so that it is a good learning experience for them. But we continually go out to get adjuncts to try to offer these courses. And they have good feedback on these. They say our students are very hardworking, they understand the problems, and they are very motivated to provide good solutions. So these are the experiential learning. This is one of the experiential learning elements that I was talking about. There are a few others that if you come to a program, you'll get a chance to go through. One of them are internships. So internships, we encourage all our students to do internships. It gives them the work skills, how to communicate with their bosses, teaches them about being punctual, how to behave during meetings, how to voice out, gives them courage to talk and defend their views and so on. So these are internships that is one of the possible graduation requirements, which I'll talk about soon. In the program, you also get a chance to go overseas on SEP. It's hard to fit into the program, but some of them, they take more courses early on so that they can go overseas. Sense-making courses, like I mentioned in the previous slide, these are run by adjuncts, and they give students a chance to build up a contact, learn about how things are done in the industry. The co-op program is something we're trying to relaunch soon. It is optional. It is a program. Now, internship is a one-semester thing. Students can go on 2 or 3 internships during their school time and with 2 or 3 companies, each time with a different one. But the co-op program is slightly different because students spend 3 semesters in a row with the same company. This gives the company a chance to get to know the student, to rotate them around different units within the company. And in this way, it allows the student also maybe to work on a longer term project and see it through from start to finish. So this also requires negotiation with the company. They may not want to have such a long period of internship, whereas some others do. So it's up to us to negotiate and try to get these positions for students. Okay, if you take the DSA program, you have to fulfill one of these 4 before you graduate. You have to do maybe an undergraduate research course with a faculty, or you do an honors project in your 4th year, or you do one internship, or you go on the NUS Overseas College program. Most of our students, they fulfill an internship. They'll do at least one. Some of them, they'll do an honors project, which is like a thesis in their 4th year. Others will do it earlier, which falls under the undergraduate research category. Okay, so 1 and 2, they are more where if students are interested in a kind of theoretical founding, they want to further that, maybe they're interested in graduate studies, they go and do this requirement for graduation. Options 3 and 4 are those who kind of are sure they don't want to get further studies at this point. They don't want to do a master. They just want to go to the workplace. So the internship and the overseas college program, it will help them with that. The overseas college program is very prestigious. Basically, the students will get sent to either Europe or maybe Vietnam in Southeast Asia, where they are part of a startup community. So they work with the startups, so they see exactly how companies are started. And a lot of them, some of them, go on to actually start their own companies. Okay, so options 3 and 4 are usually those who are more work-oriented. They want to get some work experience, or they intend to have a startup. Options 1 and 2 are those students who sometimes they want to already know they want to go to graduate school, so they want to discover whether they are a good fit for research type projects. Okay, although there are some students who do both. Some of them do an internship and an honors project, and so on. Okay. Other DSA programs we have in CHS, we also have a second major in data analytics. It's a different pathway. You have to do a different set of 10 courses to get your second major. And then for a minor, you do 5 courses, data analytics. These are also very, very popular in our department. Okay, the students that we graduate, they go to internships in many different companies in many different domains. A lot of them are in tech companies. A lot of them are in e-commerce companies. but it's a good spread. This is the graduate employment survey from 2024. I think the 2025 one isn't out yet, but at this point in time, you will see a separate line for data analytics. But after that, we were subsumed into the College of Humanities and Sciences, so you won't see a separate line for our median salary of our graduates and so on. Okay. But this is, again, this 2024, between 2024 and now, a lot has happened. AI has taken over a lot. There is a lot of companies that are freezing their hiring. There are a lot of companies that are cutting down on the staff that they have. So it has been harder for students to get jobs, but it takes a bit longer for them. But from what I've seen, a lot of them are still getting interviews and getting into positions. Okay, so how to apply is the same as any other major in College of Humanities and Sciences. So you go to this website. As long as you get into the CHS, you'll be able to choose DSA as your major. Okay, so these QR codes are the same as what we had just now, the integrative grade profile. I can show you again. For Humanities and Sciences, this is the 10% cutoff, and this is the 90% cutoff. So again, it's not a guarantee that if your grade profile looks like this, you'll definitely get in, or it's in between, you'll definitely get in. But this was from last year's intake. Okay, so I think we have about 9 minutes left. Maybe I can stop here. And if you have any questions, you can put them in the chat window, and then I'll try to talk about them. Let me stop sharing. So from the semicolon example, does one need to be very, yes. If you're a data scientist, yes, you do need to be very detail-oriented. So here's why. So when you're on a data science project, right, you don't know the answer at the end, and you are not working with a physical theorem. It's not that you can derive and prove that this is a solution that will work. Any solution that you come up with, right, it is still a tentative solution. If you deploy, you ask any company, when they deploy a data science solution, it's never that they just deploy it and then they run away. So they deploy it and they wait. They gather data to see whether it's working. And if it's not, they quickly need to fix it. So when you work in a data science, right, you gather data, you have a certain hypothesis, you try to solve it, you make certain assumptions along the way. Even if you already know the precise model you want to run, you know the precise data that you want to collect, there will be different decisions that you need to make along the way. How do I clean the data? Do I include this column on that column? Hey, this has been spelled, this person spelled Michael, M-I-K-E, and this person spelled M-I-C-H-A. Are they the same person? Their last name is the same. So you have to have a lot of decisions which lead to assumptions along the way. So you have to be able to keep those assumptions in your mind, because if something goes wrong, though one of those will have a red flag, you go back and say, oh, this is why, this was the assumption that was wrong. You go back, retract, and then you start again. So you have to be very detail-oriented. This is a good skill. It's a good. What's the difference between data science and analytics and data science and economics? Can candidates switch between these programs? The answer is no. So data science and analytics is under the College of Humanities and Sciences. So when you're in data science and analytics, you're under CHS, and then you can switch to any one of the majors. From data science, you can switch to an ST major, you can completely switch to an FASS like history major or geography, but data science and economics is a cross-disciplinary program. This one, you must get in directly. So the grade profile is different from DSE or DSC. See, the grade profile is different. There is a separate line for this. This is more competitive to get in. The cohort is smaller. I think they have a quota on the number of people that go in. So it's different. You cannot switch from DSC to DSA and DSA to DSC freely. Which is better, BSA, BZ, Business Analytics or DSA? So this is a tough question to answer. I'm not sure how we would say better. If you ask me whether better means higher salary, even then it's hard to answer. But I can tell you what are the differences in our programs and the kind of roles that a DSA majors go into compared to BZ. So in business analytics, a lot of the focus is on case studies, problem solving, working with businesses to try to craft solution, presenting them using, to a certain extent, off-the-shelf solutions, maybe using Tableau, Power BI, and so on. But DSA, we try to give you more foundation, like in the math, the statistics, and the coding, so that you can build upon existing solutions or come up with solutions from scratch. By knowing Python, you can code up a new model. If, let's say, a colleague of yours comes up with a new model, you can code it up on your own, you can test it, you can deploy it, you can write your own front end to do it. So you have that capability as a DSA major. As a DSA major, you can even go into things like data engineering. As a DSA major, you can build upon that. If you have a good math background, you can build upon that and go on to graduate school, data science, or in statistics. But the business analytics degree doesn't emphasize the same mathematical rigor and coding fundamentals that DSA does. And a lot of our experiential learning is based on this, like in-practice courses that we instill that communication, because it is an even further gap from the DSA major to the actual domain. So we try explicitly to try to bridge that gap because of our technical depth that we try to get into in the first couple of years. How can one get the domain knowledge while doing DSA? This is tough. A lot of domain knowledge comes from experience. There has to be a certain amount of patience. If you already know, the issue that I feel is at a young age, okay, so I speak from personal perspective. When I was undergraduate, I did mathematics. There was no such thing as data science at the time. But even then, I didn't know what my interest was. It took me a few years to realize what domain I want to work in, what industry, what is my expertise, what are my strengths. So it takes you a bit of time. So what I'm saying is that some of the students, they start out in a particular domain and then they will switch. And whatever they learned in the domain, some of the learnings can be transferred over. Some cannot. You have to learn from scratch. But to get the domain knowledge, if you ask me, there is little substitute for actually working in the domain for a sustained period of time and getting your hands dirty. May I ask, is it better to learn some professional knowledge like physics or chemistry besides DSA to be more competitive? Because I think only DSA might be a bit separated. So we do try to, so there was a famous statistician, his name was Tukey. He said that one of the big advantages of being a statistician at that time, I think he's the one who coined the word data scientist. He said the big advantage is that you can play in everybody's backyard. So he saw that as an advantage because you can go into different domains later on. But if you want to, and I'm not sure if, okay, when you talk about professional knowledge, if you want to basically like top up your DSA background with a specific domain, I think that's good. If you can identify certain companies or certain domain areas that you want to put on top of your DSA expertise, that's good. But DSA alone, and then you combine with another discipline like physics, there has to be a connection between the thing. For what you're going for, that you want your DSA program to show breadth and to show like application, having a second discipline alone is not enough. Perhaps you may think of geography. If you take geography in DSA, geography has a lot of data science related solutions. They do a lot of spatial analysis. There's a lot of location-based services that people are working on nowadays. So if in that sense, if you couple geography and DSA and you try to identify problems and maybe for your FYP, you do something that combines the two disciplines, that would be great. That'd be great. Does CS or DSA go more in depth into AI, ML? Okay, so within our department, we don't offer direct courses on AI, but a lot of our students, they do a second major in computing, so they take the courses directly from the computer science. We are also beefing up the courses that we cover. A lot of our projects in practice, some of them do rely on AI. We do encourage our students. We don't stop them from using AI to develop solutions and so on, but we try to get them to make sure that they understand the solution and can debug and validate what it offers. Okay. So the difference between DSA and statistics, like I mentioned just now, in statistics, there is a lot more emphasis on the methodology. So you will learn more methodological tools. In DSA, a lot of that space is taken up by coding-based courses, and a lot of the sense-making courses. And like I was mentioning, right, we do try to instill through those in-practice courses and the sense-making courses, the understanding that as a data scientist, you need to be able to know all the steps from start to finish of a data science problem. Gathering data, cleaning data, deploying the solution, hacking the solution to see where it's working, where it's not, explaining the solution, communicating, and then deploying it. So the in-practice element is something that differentiates our DSA program and our stats. So I was telling you, we have two in-practice practice track professors. It's not that they just teach these in-practice courses for our undergraduates. We actually have two master's programs, a data science in sustainability and a master's in statistics. So both of those also have in-practice courses. So our two practice track professors, they also teach the master's program. So they are very well versed in trying to get people to practice data science and statistics. So that is, if I can highlight, I feel like that is the difference, apart from the coding, in terms of the training you get as a data scientist. So there are roles that I know our data science students compete with CS students for. It depends on what you are interested in. CS degrees are more pure. Yes, you do learn the computer science and the algorithms and maybe the software packages. But our data science students, if you ask me, they focus a lot on the problem solving, how to formulate a problem, how to creatively come up with a solution for the client. So I think there are different roles, and I do see our students compete with CS students and on an equal footing. I do see our students get a lot of the positions, but if it is a pure CS degree, if it's a pure CS related position like software engineering, or it's like web development or database management, yes, our students don't have the same training. The degree scrolls be different whether one applies to CDE or CHS first and then do a double degree. Yes, it will. You will have a primary home department that you're coming from, and then that will be the one that your degree scroll indicates.
Oh, Vic, maybe I can chime in a little
Okay.
bit. As far as the double degree program is concerned, I don't think it makes a lot of difference whether essentially you're getting two degrees. So how it presents itself on the scroll is probably not the most important. I think perhaps it's the same person who asked just now. So typically, what you do is you apply to a certain faculty first. In your case, maybe a CDE. So after you study for 1 or 2 semesters and you feel that you want to go ahead with the second degree, then you can apply to the program. And typically, I think if you do very well in your primary degree, then you have a good chance of going into the second one, provided you have the necessary background as well. And maybe I also chime in a little bit about the thing between switching between DSA and DSE. So as Prof. Vic mentioned, there are basically two different lines in the application system. So it is possible for you to switch from DSE to DSA, but that means that you have to reapply to NUS again. It is like you're in law and then you want to go to business. What you need to do is you need to reapply. So that has happened for some of our students. So this situation is a little bit different from switching from math to stats or to DSA. All right, that is within the CHS. So it's a change of major. Whereas if you want to change from DSA to DSE, it's a change of degree program. So you need to reapply to that program. Yep.
So what roles in internship do students typically do? So we've seen all, like just now the slide I showed you, some of them work as analysts, some of them work as data engineers, some of them work as data scientists, AI, machine learning engineers, and so on. So it's quite a varied set of roles that they work in. Yeah. Okay, so I think we're at 5 past the hour. I thank you all for joining the session. Um, we can catch up again next Saturday during the physical open house. I'll be there. So if you have questions, maybe we can meet there and talk more. Hope to see all of you there, and have a good Sunday. Have a good weekend. Thank you very much, everyone.